Hi, sixth graders, it's Mrs. Johnson. Today we're going to be looking at 1.1 notes part 2. And what we're looking at here is motion graphing. And so what this is how can graphs show us the motion of an object? So our objective is I can create graphs for an object traveling in a straight line and explain how these graphs describe the object's motion. Our essential question is, what can we learn from motion graphs? So this is part G because it's a continuation of your other notes, all right? So how is constant speed graphed? So first we're going to use something called a distance time graph. And our distance is always going to be on the y-axis, and our x-axis is always going to be the time, okay? If we have a constant speed, we're going to have a straight line like this, okay? Now the steepness of the line, which is the slope, okay, is equal to the average speed, okay? So the slope is the change in distance divided by the change in time. So what we would do is pick any 2 points on the line and divide it, okay? So this point is at 570, and this point is at 10, it's over 10 and up 140. So we find the change in distance, okay? And so the change in distance is 140 minus 70. So the change in distance is 70 meters over the change in time. So from 5 to 10 is 5 seconds. Okay, so then we do 70 divided by 5, and we get 14 meters per second. So that's how we can look at a graph and we can calculate the average speed. So let's create a graph here, okay? So on our x-axis down here, we are going to make sure that we put the time, okay? So the right time in there. And our units, according to the data table, is in seconds. And on our y-axis, we're gonna do distance, and our data table tells us it's in meters. Flip this around, whoopsie, and then move it down here, okay? It's kind of overlapping on my data table there, okay? Then I'm gonna put my intervals on here, or my spacing. So for my time, I need to go only from 0 to 5, okay? So I'm gonna have, I suppose each of these could be 1 second, right? No, I couldn't do 1 second. So I'm just gonna have each line be 1 second here. So start at 0, and then this one would be 5, 10, 15, and so on. For my distance, I only need to go up to 10, so I'm going to use the same spacing there. So 0 down at the bottom there. 5, remember they need to be evenly spaced, okay? Then I'm going to plot my points, okay? So this is how many I go over and up, okay? So over to 0 and up to 0 is at 0, 0 right here, okay? Then I'm going to go over to 1 and up to, so over 1, up 2, and put my dot there. Over 2 and up 4. Over 3 and up 6. Over 4 and up 8. 8. And over 5 and up 10. Okay. Then what I could do is I could connect this straight line here. See if this works. Hold on. Select line. Okay, well, it's not letting me draw a line, but I could connect that and I would be able to see that this is a straight line. Okay, so what are some other things that tell us? So we know that objects don't actually always go at a constant speed. Okay, so what we can do is we can look at what happens to a line on a graph and it can tell us a story. So a change in the slope of a line indicated that the object has either sped up, slowed down, or stopped. Okay, so when a line gets steeper, that means the object is speeding up. When a line gets less steep, the object is slowing down. And if the line is flat or horizontal, the object is not moving or has stopped. So we can see right here in this graph, the object has stopped. And in this part right here, the object has also stopped. Okay. Now, one misconception that people have is that when we have a downward line like this, that means that it's slowing down, but that's actually not true. What this just means is that this is returning back to where it started, because our y-axis here is the distance away from the start. So if this was the start, right, I might say that I drove in my car, I drove 4 miles, or maybe not drove, I biked, okay? And it took me 1 hour to bike 4 miles, okay? Then I stopped at McDonald's and I ate lunch and sat down for about a half an hour. Then I continued biking and I biked for another hour and I biked 4 more miles, okay? Then I stopped, I made it to the park. I sat down on a bench and I read my book for an hour, not moving. Then I biked all the way back home at a constant speed. And it took me from 3.5 hours to 5.5 hours. It took me 2 hours to bike home. And I didn't stop at all. So that could be a story that would go with a graph like this. Velocity is speed in a specific direction. So if you look at like this picture right here on this chairlift, so these guys are going the same speed, but they don't have the same velocity because these people are going, let's say, to the north, and these people, let's say, are going to the south, even though they're moving at the same speed. Okay, so it is possible for two objects to have the same speed but different velocities, like this chairlift. Okay, two birds could be flying at the same speed but in different directions, so they would have different velocities. All right, so we're going to try another graph, and we're going to make a motion graph here. Okay, so first we need to put our labels on. We know that what do we put on the bottom? We put time on the bottom on the x-axis, so this is going to be time. And it looks like my measurement in my story is in seconds. My distance goes on the y-axis, and this looks like I'm measuring it in meters. Box a little bigger there. Flip it around and move it over. All right. So here's my story. Okay, so I'm going to start down here always when I'm making a distance time graph. Okay, so an otter swims 100 meters in 30 seconds. Okay, so each of these is going to be 5, 10, or 10, 20, 30, 40, 50 seconds. So we're going to start at 30 seconds, and he went all the way up to 100 meters. So my first dot is going to go all the way up there on the top. Okay. And actually, my first dot is going to be my start. So my first dot is actually going to be at 0, 0 there. Okay, so I start at 0, 0. And then my otter swims for 30 seconds. He swims to 100 meters. Before he gets lazy and drifts along 50 meters in 20 seconds. Okay, and I am realizing that I need to change my distance here. So I'm going to actually take this off because he goes 100 meters and then he goes 50 more meters, right? So I need to change my measurement here. So I'm going to use the same measurement that I used along the bottom there. Whoops. Sorry about that. Thought I had it all ready for you. Okay, now let's try it. All right, so we start at 0, 0. So the otter swims 100 meters in 30 seconds. So we still go over to 30 and up to 100. Okay, then it says he gets lazy and drifts along 50 meters in 20 seconds. So he's going to go 20 more seconds to 50, and he's going to drift 100 or 50 meters. So 50 added on to 100 is 150. Okay. The otter then relaxes on the riverbank for 10 seconds. So he's not moving. So his 10 seconds is going to be right here. Okay. Then what I'm going to do is connect my lines here. Okay. See how straight they get. That's not a very straight line. I'm going to erase that. We'll go with it. Okay. Connect those dots. And then connect these dots. So what we can see then when we look at this is we can see that this line is much steeper, not much steeper, but it's steeper than this line. And that tells us that he was swimming faster. The speed was faster, and then he slowed down a little bit. And then because this is a straight line, that means that he stopped. All right, so we are going to do some more activities with this week, and we are going to be looking at some motion graphs that will show us stories, and we'll also look at stories and make motion graphs from those.